0. So here we give it, the number that we give here is 98, but they want us to give 0. So now I believe we can go and start working on our solutions. So now I have already opened my webcam, so I'm going to move into it. Let me first know where I'm at. I'm in root, so let me see the directories that I do have. I have ALX low level and ALX system, so let me move into ALX low level and lists. So I don't have the specific one that they are asking, which is this directory, so I need to create it. I'm going to create it quickly, mkdir. And the next thing I want to do is move into it. So cd and move into it. And do ls to see all the files that I have inside this folder. And let's do pwd to actually know where we are currently standing. So we are now in the folder or the directory called 03 debugging. So now we need to create our readme. So vi readme.md. And the next thing that we need to do is input something in it. So I'll just quickly put the name of today's tasks and today's content, which is 03 C Debugging. Paste it there and then save it, because our readme should not be empty. And the next thing I want to do now is look at the task that they want us. So they want us to have 0-main, and they also want us to have main.h. So the first thing I want us to do is create the main.h, and what main.h should have, it should have all the prototypes that we will be having. So our prototypes are pretty simple to get to know. This is the prototype, which is for this specific one, for these multiple main tasks. If we move to the next task, we also have the prototype as well, if it will be there. So just look at each and put the prototype. So personally, I had already put all the prototypes that I will need in one folder for ease of today's session. So these are all the prototypes and all the things that I need. And I will create main.h, and I need to copy all these prototypes that I have over here. So let me put these prototypes I have, and then now save. And now the next thing we need to do is create the 0-main.c, because they told us you only need to upload these two, 0-main.c. So this is the file I'm going to upload. So I need to create it. And as it is being created, they have told us to change this code such that when we have the value 0, our function positive or negative will be able to check whether it is either positive or negative. So the other thing that you can do is create the positive or negative function itself and the file itself, and I think we can do that right now and look at it. But before that, let us copy this and edit it accordingly. And I already have my answer. Let's go to my answer. I've just copied the solution as it is, and this is it. So if you go back and check out the other one that they have provided, this is I is assigned 98, but what they want us to do is assign it 0. So I'm going to copy this because this is what they want us to do. I'm going to copy it in here and exit and save it. So now if we have to do ls, we will see all the files that we have. We have the readme file that we had initially, we have main.h, which contains all the prototypes, and we have 0-main, which will have the solution to the first task. So the next thing that they want us to do is make sure that it runs accordingly. So it will run accordingly, and what they want us to do is run this option. But if you see in this option, we have positive or negative.c. So this file needs to be present, but they have also mentioned that they will provide their own. But what I want to do is I just want to provide this file, so I will create this file for ease and also for you to be able to know how to do it next time. So this is the file, positive or negative. And as it is loading, I'm just going to look at my solution. So this solution, I had picked it from one of the early solutions that we had actually worked on, and I can't remember the name, but it is somewhere. So let me just copy it as it is. And what this program will do is it will pick the integer that the user has provided or has been provided and check if that number is less than 0. If that number is less than 0, then it will print that number. Percentage D is a placeholder for that, and it will print that specific number. Whatever number I have provided, it will be input here, and the next thing it will print is it is negative. So this piece of code, this if, checks if the number I have provided is less than 0, and if it is less than 0, it will print that number is negative. Now, if it is not less than 0, that means it is either greater than 0 or 0 itself. So the first thing I want to check is it greater than 0? And this is that piece of code. So what this does is it checks that the number I have provided is greater than 0. And if it is greater than 0, it will say that it is positive. And the last one is that number is neither negative, less than 0, or greater than 0, but it is indeed 0 itself. And what I have highlighted in blue is it will be 0 itself. So let us copy this. Let us copy this and have it in our positive or negative file. There it is, and we save it. So now we can escape and save it. And now we can run Betty and we just see that these files are okay. I'm just showing you how to run Betty. You don't have to run it all the time if you're already used to Betty. Personally, I am used to Betty, but if you're not, kindly just make sure you run Betty through all your files. So let's go back to our questions and see. So what they want us to do is now be able to run this. So once you run this and it gives you this specific options, it should give us 0 is 0. Why should it give us 0, 0? Because we initially initialized I to 0. I hope you remember, because that is what they wanted. Give the correct output when given a case of 0. So the output it will give us is 0 is indeed 0. So let's run this GCC option. Hope it will give us that. It is running. As it is running, one thing that you can notice today is that we don't have any checkers. I don't know if you do have, but personally I don't. So now let's run this option that is here, and this should be able now to run that executable file which has been produced at the end of the GCC compilation process. So if we run this, it will give us or print 0 is actually 0. And yes, so now we know that our code is actually correct. It is giving us 0 is 0. So even if we give it any other number, it will be able to actually run and either tell us if it is positive or negative or it is 0. So now we can clear this and go to the next question. And the next question is like, comment, or subscribe. So here they are telling us to copy this main file and comment out. And we're not supposed to delete, just comment it out, the part of the code that is causing the output to go into an infinite loop. So please read the instructions carefully. They have told us do not add or remove any single line of code because they will be checking the line count, and you are only allowed to comment out the existing code, and they're also telling us that we don't have to compile it with these options for this specific task. So what you're going to do is you're going to create this file. Let's create it, vi, and as it is being created, this is the code, and I want us to go through this code. So when this code is like this, what it's going to do is it will execute, and the first thing it will do is load this library, and then these are just comments to tell us or any other person who will be using this program what it is. This is the main function where the program will start. We are declaring I, and after that we are printing this, and it's just statement saying that an infinite loop is coming. So what will happen is the first thing this main function will do is it will create a space in memory called I, and it will print this, and then after that it will initialize now I to 0. So the next thing is we are using a control statement, and here we are using while, and what it is checking is as long as I is less than 10, it will put character I. So this is the control statement and its body, that's the entirety of it. And after that we have printf, and what this will do is just it will print infinite loop avoided. So if you have already seen this, before we comment out anything, the program will enter the while loop, and this is the while loop. This is the while loop, and it will start printing out the values of the variable I. This is what I'm talking about. This is the variable I, and it has been initialized to 0. So these values will never ever change, because inside this loop the condition has just been set to I is less than 10. So this will always be true because I is 0. So it will always be 10 if there is no any other statement to update it or to control it. So at the end of the day, this while loop will continue running forever because the value of I is constantly and permanently 0. So this is the piece of code that we need to comment out, and when you comment it out, the program will execute properly, and it will move to this next step and print this and execute this successfully and terminate normally. So the program will run in sequence, but when it reaches this stage, it will stop here and be in an infinite loop. So this is what we need to correct. So I had already commented it out below, so let me just copy it. I had already commented it out, and this is the solution for that task. And I'm going to paste it there and save it. And now once we save it, we know that that is okay. We can quickly see what we have in our file. So we have successfully commented it out. Here, what I'm highlighting, we have commented out the while loop, which is preventing our program from running successfully and terminating normally. So at the end of the day, when we run this, it's supposed to print out two things. It will print out this, which is a fast printf statement, and it will actually get to this point and print out the next statement, which is infinite loop avoided. So at least now that is okay. We can clear this. We can clear that, and we can actually run this GCC option and see what happens when we run that code. Let's paste it here, and it will give us these two, which is what I had mentioned earlier. It will print infinite loop incoming and infinite loop avoided when we run this option to run the executable file that is provided or produced at the end of GCC compilation. And yes, that is our solution. So now at least you know we are on the right track because we don't have any checker to use today. So the next thing that they want us to do is to print the largest of 3 integers. So before we do that, let's clear. So what they have done is they have given us this 2 main.c file, and it contains three values A, B, and C. A has been set to 972, B is a negative 98, and C is 0. So here we can see we have three values, and we have a function largest number, which will pick the largest out of these three, A, B, and C, and A has been set to 972, B to negative 98, and C to 0, and it will store the largest in a variable called largest. And then after that, it will print the largest number. So it will actually print that specific value. This percentage is a placeholder for that number, and it will say is the largest number. I hope you got that one. So we need to create this file, create it so that now we're able to put in this that they have provided for us over here. So that is that. We place it there and we save it. And now the next thing that they are giving us is this function. Sorry, this program called toLargest.number. So what it does is it is referencing the main.h library, which is a user-defined library, and these are comments that tell us what this program is doing. It's just supposed to return the largest of the three numbers, where A is the first integer, B is the second, and C is the third. So this is the function, and it's taking in integers A, B, and C, and int largest is the variable that will have the largest. So here we're just declaring that variable largest, which is more or less creating a space in memory. So the next thing that is happening is it is checking is A greater than B and is B greater than C. And if these two conditions are met, then it will pick A as the largest. So these two conditions need to be met, and if you remember, if you're using AND, it means both conditions need to be met and not one, both need to be met. So the next thing it will check if these two conditions are not met is, it will check if B is greater than A and if A is greater than C. So what that means is, it will check first if B is greater than A. And then now, if that is satisfied, it will move to the next step and check, okay, now that B is greater than A, is A greater than C? And if these two are satisfied, then B will be the largest and it will be stored in the variable largest. Otherwise, then the largest by assumption or by default is C. So if we notice, this is not very intuitive because it will give us and tell us that 0 is the largest, which is not right, because from the values that they have given us above, A is 972 and that is the largest. So now we need to correct that and store it in a file called toLargest. So what we need to do is fix the code above and store it in toLargest.c file, so that at the end of the day it will give the correct output and print which of the three numbers is the largest, irrespective of the case. So not just for this, but whatever values you give it next, it will give you the correct output. And here they're also telling us that the line count will not be checked for this specific task. So you can feel free to edit it as you wish. So I had earlier done that. So let us look at our solution. So here we do have the same, but I have edited it to be more intuitive. So remember that we do have to have A, which is 972. And then we have B, which is equals to negative 98, and then lastly we have C, which is equals to 0. So the largest is A. So it will tell us that A is the largest. So here we are going to check, is A greater than B and is A also greater than C, which is true. So it will print the largest is A. And after that, we have else if. So if A was not the largest, it needs to move now to this next else if statement. And here it's supposed to check, is B greater than C? So if B is greater than C, then we move to the next step and check, is B greater than A? So at the end of this specific step, B will be considered the largest and the value of B will be stored in the memory location or the variable called largest. Now we've not checked whether C is the largest. So this is what it does next. Because now we have already established that A is greater, and since A is greater, it is greater than both B and C. So the only thing remaining is now to check if C is actually greater than B, because from this one we already know that A is greater than C. So if this is satisfied and if this is met, then the largest is C, and if all of these are not met, then the largest is B. So after that, it's supposed to return the value or print out the value that is the largest. So now let us copy this and put it in our solution. We have already created, I don't think we have, so let us do ls, sorry, it will be in small. We don't have it, so let us create this file to largest number. So we do vi, and as it is opening, we can copy this and paste it inside that has been successful, and save it. So now the next thing we need to do is try and run our GCC so that our files are compiled and we get an executable file called to-main, which you can now run and it should give us the correct output, I hope. So I hope you've been able to follow so far and everything is clear. So now we can run or execute our executable file and it should give us 972. So we hope it will give us that output. And indeed it has given us that 972 is the largest number. So even if you want to put in other numbers, it will give you whatever number of the three that you have provided is the largest. So now I want us to move to the last task. We need to clear this first so that we're able to start on a clean slate. And here we have given us a program that will convert a date to the day of the year and determine how many days are left in that year, and it's supposed to take even leap years into consideration. So normal years have 365 days, but leap years, they do have 366. So irrespective of whichever date this program has been given, it's supposed to tell us how many days are left, including a leap year. So the first thing that they have given us here is this 3-main underscore a.c file. And if we copy this file, let's copy it. Okay, no, we should not have done that. We need to delete that file we have named v. Let me just delete it right now. I hope you remember how to delete files. You use rm.v, so vi, which is to create the file that we actually intended to create. So what this will do is it's supposed to take the date and print how many days are left, taking into account even a leap year. So I hope, let's copy it again and paste it here. There, and then now we can skip. So what this will do is it will have memory location for the month, for the day, and for the year. And here we are checking the first day of the fourth month of 1997, and they should be able to convert everything and print the months, day, and years that are remaining. So the next thing that we need or we have been given is is 3 convert underscore day. So what this program does is it will just convert the day of the month to day of the year without accounting for a leap year. And we have two variables. We have the month, which is the month in number format, and the day of that month, and it will return the day of the year. So this will either tell us which day of the month it is. So the next thing that we have is this 3 print remaining days, and this what this program will do is it will take a day and print how many days are left in that year, and it will also take into account leap year. So this is what they want us to do. And if we continue down and read the instructions, what they're telling us to do is we need to fix print remaining days function so that the output works correctly for all days and all leap years. So here they're also telling us they don't mind how many lines it will be, and we want to check it. And also they're telling us that you can assume that all test cases have valid months. So what that means is, so what they're telling us is you can assume that all test cases have valid months. So what they're saying is the value of the month will never be less than 1 or greater than 12, because we only have 12 months in a year, and it starts at the first month, which is 1, and the value of the days will never be less than 0, because you can never have 0 day, and it will never be greater than 31, because all months must end at the 31st day. And they're also telling us that you can assume that all test cases have valid month-day combinations. So there will never be June 31st or November 31st, because this month end at 30th. I hope you got that one right. So let's look at print remaining days, the wrong output, the wrong program that they have given us, and what it does and how we should be able to fix it. So I think this is it. Let me check print remaining days. Yes. So this is it. So what this is doing is this C function, this one, this C program, it has a function, called print remaining days. It has print remaining days. So what it does is it will take 3 arguments, which are the month, and then the day, and then the year. I hope you got that one. And then after that, it will go ahead and calculate how many days are left in the year, and it will take into account leap years, and it will print the results. So what happens here is it will check if the year is a leap year by checking first if it is divisible by 4, and if it is not divisible by 100, or if it is divisible by 400. So if it is a leap year, then it will adjust the count of the days. Here it is, it will adjust the count of the days, and then include that extra day, which in this case is February 29. It will adjust it, and then after that it will print the day of the year that it has encountered and the remaining number of days for that specific year. And then now the next thing is the else statement. So if it is not a leap year, what happens? That is what it is telling us. If it is not a leap year, then it will print the day of the year, that specific day of the year, and the remaining days of the year without any adjustment to it, because we don't have an extra day. And if the input date is invalid, that means it is February 29, but it is not a leap year, which can't happen. Then the function prints an error indicating that it is an invalid date. I hope you got that one. So at the end of the day, this program is just designed to provide a very simple way of calculating the number of days left for that specific year that you're looking into, and it will also take into account leap years. So now I want us to look at the solution which I had earlier researched. This one is a bit complex. To be honest, it also gave me a bit of a hard time, but let us look into it and I will try my best to explain what is happening. So what we have here is we have the libraries as usual. These are the libraries, and we have the comment of what it is doing for someone else to be able to understand what it is doing. So here we still have the same name of the function, print remaining days, and it will still take 3 arguments into it, the month, the day, and the year in integer format. And then, like the previous one that we looked at, it will now calculate how many days are left in that year. How many days are left in that year, and it will include even leap years, and it's supposed to print the results. So the main difference between this one and what is in the solution, in the tasks that you're supposed to solve, is the previous one in the way the leap year is calculated, and this one to do it differently. So here, leap years are identified, or we'll get to know leap years by dividing that year by 4, except now for years that are divisible by 100, which are only leap years, and if they're also divisible by 400. So if I'm to explain this is in a more accurate way, it will be to determine leap years, and it will take into account the fact that some years which are both divisible by 100 and by 4 are not actually leap years. A very good example is 1900, and it is not a leap year, but it is very divisible by 4 and also divisible by 100. So the previous function will pick it as a leap year, but in our current program and our current function, it will not, because here we are checking that it meets these 2 criteria, that a year is divisible by 4 and by 100, which is the same as it being divisible by 400. So in that case, 1900 is divisible individually by 4 and individually divisible by 100, but in combination it is not divisible by 400. I hope you got that one right. So at the end of the day, if the year is a leap year, then the function checks if the input date is 29, and this is what I'm talking about, and it will eventually adjust the count accordingly, which will be to add 1 day, and then now after that it will print the day of the year and the remaining number of days that are remaining. The other one that will happen is if it is not a leap year, then it will carry on normally as we had earlier explained, and it will continue, and the function will print the day of that year. It will print the day of that year, which is this, and the number of remaining days that have been left. And if the input is invalid, meaning that it is 29, which is this, if it is 29 and it is not a leap year, then the function is supposed to print an error message that will tell us that it is an invalid date. So this specific program covers all grounds for leap years, for invalid dates, and for years which are not leap years. So at the end of the day, this function is similar to the previous one, but it uses a more accurate way of determining the leap years, and the only difference is here, because it will check that leap year is divisible by both 4 and by both 100, which is the same as it being divisible by 400 and not individually. So let us copy this code and put it in our solution. As it is opening, we can copy this. You can copy the rest of this. Yes, there it is. And paste it there and save it. And now the next thing we need to do is go and check if there are any more instructions that they need us to do. So they want us to run the GCC. And they want us to have the file, which is 3 convert days.c, which is this, and 3 print remaining days, and 3 dash main b.c. So let us see if we have those files for us to be able to run our compiler. We do have 3 remaining days, so we don't have the 3 convert days, so we can actually start with that one. They have actually provided that code for us, so let us start there and we look for that. What it does, it helps us convert the number of days we remember correctly. Where is it? And it is this one. So just copy it as it is. Yeah, copy it as it is, and then we place it in our file, and then we save. The next one that we were missing, if I remember, is 3-main.b. Yes, but yes, we were missing that one, the one that will check if the leap year, for leap years, which is this. So it's the very same file as 3-main_a, but we're just going to change the dates that have been input there. So now we can actually get the code for that. Let's copy the name of the file first, so that we don't make any errors. And we can now copy the code for that file. Yes, this one, but you're going to change it a little bit. So, sorry, let me copy it again and put it here. But they've told us to use it for a leap year. So where is it? Where is it? They want us to put 29th of February 2000. So we just need to change the days that are in this file. So the year they've mentioned is 2000. Yes, and the day is 29th, and the month is February, so its month should be 2. Yes. So now we can save our file and check if we have all the files that they need us to run the GCC option with. So I'm going to do ls to check all the files that we have. We need to have 3 convert days, 3 print remaining days, and 3 main b.c. So we have 3 main b.c, which is a good one. We have 3 print remaining days, and we eventually have 3 convert days. So now we can run our GCC to compile our files, and then after that we should go ahead and actually get an executable file called 3-main_b, and we're now supposed to run that file and see if it will give us any output, and the output it will give us is this is the output it should give us. So let us run this and hope it gives us the correct output. So it is giving us the date which you have provided, which is 29th of February 2000, which is a leap year. The number of days for that year, so far it's 60 days, and the number of days remaining is 306. So at the end of this specific leap year, we will have 60 plus 306, which is 366 days, and that tells us that it is a leap year. So we have come to the end of debugging. I hope everything is good so far and you've been able to understand most of the concepts. If not, just keep on going over the content, over the quizzes, and over the tasks that have been provided. Discuss it with a friend for you to be able to understand it better. And if you need further assistance, don't shy away from commenting down below, and we will definitely come to your rescue. So thank you for watching today's video. Until next time, happy coding.